the PDF, download it now at www.nijayacademy.com. Click on Digital Products. Select the product you want to download. Click on Buy Now and complete the payment to get full access.
Hello, welcome back everybody. Welcome back to Nijay Academy. First of all, I'd like to wish a happy Raksha Bandhan to each and every brother and sister of mine who is watching this video, right? And coming to this particular topic, right? So science and tech video was supposed to come out on Saturday or Sunday, but because of the various festivals that were associated with this particular weekend, the video is coming out on Monday. Okay, so welcome back. And today we'll be dealing with NISAR, that is NASA ISRO Synthetic Aperture Radar. Okay, so the name itself suggests that there are two countries involved in it. Basically, NASA and ISRO are space agencies, right? So NASA belongs to USA and ISRO belongs to India. Now these two agencies are coming together and they are bringing out a joint collaboration, okay, using an instrument called as SAR, that is Synthetic Aperture Radar. Now they are launching this particular satellite into a particular orbit called as the Sun-Synchronous polar orbit. And to launch this particular satellite, they are using a satellite launch vehicle called as GSLV. Okay, so let's get into the details of it. So the full form you already know it, that is NASA ISRO Synthetic Aperture Radar. The launch date is somewhere around 30th July 2025, and it was launched using GSLV, as I have already told you, and it has been launched into the Sun-Synchronous polar orbit. As I told you, the partners are NASA and ISRO, that is USA and India. Now this particular instrument uses two types of frequencies. That is why we are calling it as a dual frequency synthetic aperture radar. Okay. Now what are those frequencies, etc. and etc. we'll be dealing with in the later slides. Okay. Right now try to understand that there are two types of frequencies that are being used by it. Okay. Now the weight is somewhere around 2800 kgs approximately. Okay. This is not a precise weight. Next, the orbit is Sun-Synchronous polar orbit, and the altitude of that particular orbit is somewhere around 750 kilometers. Okay, altitude in the sense we are calculating it from the base of the Earth. Okay, right. Next, the mission is somewhere around mission life is somewhere around 5 years, and NISAR, this particular instrument or this particular satellite, is going to help us map the entire Earth in 12 days. Okay, always remember, in order to map the Earth, we are always using polar orbits. Okay, now why are we using polar orbits? It is for you to mention in the comment box. Okay, there are different types of orbits. Okay, there is equatorial orbit, there is polar orbit, and there is inclined orbit. Okay, now why are we only using your polar orbits in order to map the Earth? That is the entire map of the Earth, right? So you have to tell me in the comment box below. Okay, it is a low Earth orbit. As you have seen, 750 kilometers is it falls under low Earth orbits. Okay, now how are we differentiating low Earth orbit, middle Earth orbit, and high Earth orbit? It is for you to mention in the comment box. Okay, so there are different types of orbits. There is something called as low Earth orbit, middle Earth orbit, and high Earth orbit. Okay, now you are supposed to tell me how are we differentiating that. Okay, this is a part of your space, that is particularly in science and tech. There is a separate chapter called as space, and this is one of the most important basic parts of that particular chapter. Okay, so please go through it, try to understand how are we differentiating low Earth orbit, high Earth orbit, and middle Earth orbit. Okay, and coming back to one of the most important things that has been mentioned in this particular slide is your GSLV. Okay, now what is GSLV? GSLV stands for geosynchronous or geostationary satellite launch vehicle. Okay, now try to go through these words. Okay, SLV stands for satellite launch vehicle. Satellite launch vehicle is nothing but a rocket. Okay, it is an object which helps us get into the space, outer space. Okay, so there are various types of satellite launch vehicles which are being used by ISRO nowadays. Okay, one of them is your PSLV, that is your polar satellite launch vehicle. Second one is your GSLV, called as geosynchronous satellite launch vehicle or geostationary satellite launch vehicle. And then you have SSLV. Okay, SSLV stands for small satellite launch vehicle. Okay, I hope this is very, very clear, right? Let's go to the next slide. Now, in this image, you are able to see NISAR, right? The satellite itself. This is nothing but the antenna of the satellite, right? So this is the entire panel or the delegation, okay, with respect to this particular mission. And here you are able to see Mr. Somnath, who is the chairman of ISRO, right? So what is this SAR? Okay, synthetic aperture radar. Okay, it is a radar system, okay, which is used in development or in capturing high resolution images of the Earth, and it uses particularly the microwave signals. Okay, so what is it? It helps in capturing high resolution images of the Earth using microwave signals. Okay. Now try to understand this. If you have a bigger lens, okay, you will be able to capture large pictures. Okay. But in the case of space, you won't be able to capture large pictures. So for that purpose, what we are doing is we are using a small antenna, okay, which is going to various positions and capturing the image. Consider, for example, I am the image. Okay. Now, what is this particular instrument going to do? It is first going to take image from this particular position. Okay. This particular angle of mine is going to get covered in that particular antenna. Second, it is going to come to this position. Third, this position. Fourth, this position. Fifth here. Sixth here. So basically, it is going to take pictures from various angles. Okay. Then it is going to club it up completely. Okay. It is going to mix it up. Okay. When it mixes it up, the entire image is going to get generated. Okay. From various angles, the high resolution image of a particular object will get generated. So this is what NISAR is trying to do. I hope you are able to understand this. Okay. It is used to develop basically two-dimensional and three-dimensional images of the surface of the Earth, and particularly, okay, and particularly it is directed towards the changes on the surface of the Earth. What are those changes? Okay, first is the ecosystem changes. Second is the deformations that are present on the Earth. Basically, there might be landslides, there might be volcanoes, etc., etc. And at the end, it is also dealing with cryosphere sciences. Basically, the ice caps that are present on the north and the south pole of the Earth. Okay, so it is trying to understand the changes in the ice caps as well. Okay, so this is everything with respect to your SAR, that is synthetic aperture radar. Now I told you that it is using dual bands. Okay, one is L band and second one is the S band. Okay, the L band has a higher wavelength, so it is able to penetrate deep surfaces. So it is used in subsurface evaluation, or in it is used to understand basically the changes in the subsurface. Okay, the S band has a shorter wavelength, because of which it is used to understand the changes on the surface of the Earth. So that is what has been mentioned there. It penetrates deep through the vegetation, ice, and good for biomass, glacier, and subsurface studies. Okay, whereas S band, because of its shorter wavelength, it is sensitive to soil moisture, agricultural patterns, and surface deformations. Basically, everything on the surface of the Earth. So L, it can go beneath or under the ground, whereas S on the surface. Okay, it is very simple, and it is using the combination of both. That is, L band and S band are used in combination, because of which it is going to give you a much better data with respect to the Earth. Okay, so it also has a day and a night capability. That means there is no particular rule that it is supposed to be used during the day itself. Okay, it can be used in day as well as night. Is it clear? Right. Let's go to next slide. So here we have mission objective. So first is the climate and environmental monitoring part, right? You can read it. Right. Second is the disaster risk reduction. Basically, we will be able to understand where a particular landslide is going to occur, or where a particular volcano is going to erupt, right? Second, in agricultural crop yield estimations, basically to understand the mapping of water irrigation facilities, etc. and etc. Next, we have water resources, basically mapping of the groundwater depletion or groundwater table. And then we have urban and infrastructure, basically dam safety, right, bridge safety, or bridge analysis, stability, etc. That also can be done through this particular instrument. Now, the most important part here is, what is sun-synchronous orbit? Okay, sun-synchronous orbit is nothing but a near polar orbit, okay, where the satellite passes over the same part of Earth. Okay, when the same position of the sun can is reached. Okay, in other words, consider there is a satellite. Okay, it is going around the Earth like this. Okay, now at a particular position, okay, it is going to, when it comes at a particular position, consider this is 6 a.m. in the morning. Now the sun is somewhere here. Okay, that means every day it is going to come at the same position. Okay, when the sun is at the same position. Okay, it is also going to come at the same position, and the sun is also at the same position. So these two things will be achieved simultaneously. I hope this is very clear. Okay, so it keeps the sun's angle, okay, in synchronization with its movement. Okay, right. So what are the problems with NISAR? Okay, First of all, the most important part here is the funding. It is taking a funding of nearly 1.5 billion. Okay, one of the most expensive Earth observation projects. Second is the space debris risk. They are telling that the mission objective will be achieved within 5 years, and after that, it is going to get converted into space debris, right? Which might further cause issues with the other satellites, or which might collide with the other satellites, okay, leading to Kessler syndrome, right? Third is the international collaboration. For example, consider today Mr. Trump is trying to impose certain amount of sanctions on India. Tomorrow, if this aggravates, then that international collaboration might deteriorate. Is it clear? Because of which this entire NISAR project might come to a halt. Even after such funding, it might come to a halt, right? Next is the dual frequency which we are using. It will create huge amount of data. Second is the 12-day revisit time. Basically, tomorrow if something happens on the surface of the earth, I will get to know about it probably after 12 days, because it will take nearly 12 days to map the earth, completely mapping, right? And the last one is data security. Basically, we are sending data to USA and USA is sending data to India. So there might be issues with the data security part as well. Okay, so that should also be considered here. Now, this is one of those MCQs which you are supposed to solve. Okay, which one of the following statements about NISAR is correct? It is world's first dual frequency radar imaging satellite. Second, it can only operate in daylight conditions. Third, it will be launched into a sun-synchronous orbit. Now, if you look at the options, they are very, very similar to the recent pattern of UPSC. Okay, only one is correct, only two are correct, all three are correct, and none of the above is correct. Okay, so I'll give you 2 minutes time. Okay, you can pause the video here and take your 2 minutes, right, and decide what is the correct answer. Okay. Right. I hope you have paused the video for 2 minutes, and I hope right now you have also got the answer to this particular question. Now let us understand the answer to this. First of all, if you look at the option 2, right, it can only operate in daylight conditions. I have already told you there is no such requirement. Okay, since it is using radars, okay, particularly remote sensing, right? For that, you don't need any daylight condition. Is it clear? It can be used even when it is cloudy, it can be used even when it is night time, right? So if you take out option 2, you are only left with two things. First one is correct, and the third one is also correct, because sun synchronous orbit. That is also correct. So only two options are correct here. Okay. Right. Next, coming to the mains masala part here, there is a possibility that a question on this might appear in your mains examination of UPSC or KPSC. So you can go through this particular question